Oh, sorry, I was on mute. So, hello everyone. My name is Rohan. I'm the academic associate for Let's Upgrade, and welcome to the Machine Learning Zero to Hero course. And let me tell you, it is a great course, and you will get to learn so much from it. And I hope that you are interested in such courses. So, let me tell you a few things before our trainer comes in and starts the session. Basically, let me tell you first that you have to register, which will be given by the mod, of course, after the session starts. And after registration, basically, let me tell you one thing: you will be getting a certificate, and the certificate is, of course, for participation, which is based upon your attendance for the whole sessions, which will be in the coming up days. And the next thing is the certification for completion, and it is as per your exam, and exam will be held as per your registration email ID only. So you have to register, and the exam link will be given on that mail ID only. All right. So without wasting any further ado, let's bring up our trainer. Moderator, is the trainer there? Has he joined in? Hmm. Wait a second, guys. All right. All right. So Shivam is here.
Yeah.
Oh, sorry. There is some technical glitch, I believe. Let's wait.
Yeah.
All right. Hi, Shivam.
Yeah,
So,
hi.
guys,
Hello.
Shivam is our trainer, and let me tell you one thing: he's a great trainer, and I believe he'll be able to solve all of your doubts. And we'll be making a session which will be great for you and great for us as well, because we both will be getting to learn so much from him. So, without any first wasting any other time, let's begin with our session. All right, sir.
Yeah, sure.
All right, so on to you now, and I'll be leaving. And also, let me tell you one thing: I'll be coming after a few minutes, I believe after 30 minutes, and I'll be announcing a winner. So let's keep it a surprise. So, yeah, that is it. Bye, sir. You may continue now.
Yeah, sure. Thanks, Ron. Thank you for your introduction.
Yeah, yeah.
Okay. Yeah, hi guys. Good evening. I hope you all are interested in starting this machine learning series, and I'm also interested in teaching you all the stuff. So I'm Shivam Kole, and I'm a data scientist with around 2 years of experience, relevant experience. So let me share my screen. Just a second. I'm starting the presentation. Yeah, and let me know once you see my screen. Just say visible in the chat so that I get acknowledged here. Guys, my screen is visible. Hello. Guys, can anyone confirm if my screen is visible or not? Okay, great then. Okay, let's start. So we will begin with introduction to machine learning. Now the thing is, you might be confused, like uh, what are some things in machine learning, like what are the difference between three fields like AI, machine learning, and deep learning? What's the difference between all these three, right? So if we talk about AI is basically an advanced technique that includes your machine learning as well as your deep learning, right? So it's basically a technique that enables machine to exhibit human like behavior or intelligence. Got it? If we move towards machine learning, then machine learning basically uses some mathematical statistical concepts that enables the machine to improve with experience. So it basically predicts what is going to happen in the future, right? Now if we talk about deep learning actually uses the concept of your brain neurons, right? So it basically imitates the functioning of the human brain to solve the problems, right? So this is the difference between all these three. And if you see here, artificial intelligence is the you can say the overall shell. It includes machine learning and it includes deep learning, guys. Now guys, if you have any query or any doubt, feel free to write your doubts in the chat window. I'm happy to answer. Okay, so now if you see here, just okay, let me show my laser pointer here. Just focus on this icon, okay, on this image here. So first technique, now we will study what are the types of machine learning, right? First technique is known as supervised machine learning. Now supervised basic machine learning basically means that you have some data, okay, yeah, and you know what you want to predict, right? So that thing is basically called as target variable. I will show you a data set, so you'll be clear. Now if you read here, it makes the machine learns explicitly. Data with clearly defined output is given, okay, and it predicts the outcome and or the future. So if you see here, there is a book inside, and an eye is watching over it, and so basically the eye supervising over this book. Okay, so it's learning the pattern inside your data using the target variable and the other data. Got it? Next type of machine learning algorithm is your unsupervised learning algorithm. Okay, so if you take a look at this picture, you will see a book and the eye is closed. That means the machine, we are not providing the target variable to machine basically understands the pattern inside the data. It tries to identify what it wants to predict. Okay, now if we talk about the difference between the supervised and unsupervised method, supervised learning basically predicts something, while unsupervised learning categorizes something. So it divides your data in some specific category, right? And the last type of algorithm that we will see is reinforcement learning. So reinforcement learning is a highly advanced technique that is basically, you can say, it's close towards AI. So it's an approach to artificial intelligence. Now this technique is, if you talk about reinforcement learning, so it's basically, we have an agent is, let's say, there is a company called Sony. I hope you know Sony, right? So Sony has created a robotic dog and its name is Aibo. So what Aibo does, Aibo is called an agent, and wherever it is placed, that particular scene or an environment, it's called an environment. So Aibo learns from the environment. It learns what is happening around it, and it learns whether it's doing the right thing or a wrong thing. So that is basically your reinforcement learning, and it works on the reward and loss feature, reward and punishment feature. So if it's doing the right thing, then your model will be awarded, else it will be punished. Okay, and in this series we will be focusing on the supervised learning algorithms. Now believe me, there are a lot of algorithms and you are going to learn a lot of things. All right, so if we see here, so this is a data set in which you have to predict whether the person is having COVID disease or not. So it's a supervised learning data set. So here you have this body temperature, cough, and chest pain. And on the basis of these three columns, you have to predict whether the person is having COVID or not. So basically you have a target variable. You know what you want to predict, right? So this technique is called supervised learning. On the other side, unsupervised learning, here if you see, you don't have a target data set. You are given the data set of body temperature, cough, and chest pain, but you don't know what you have to predict. Okay, so your model will find some patterns inside the data, and it will cluster your data or categorize your data. Got it? So this is the difference between supervised and unsupervised learning. Now let's understand this technique in some layman cartoonish way. Okay, because I can see that, or I think that you all might not know what machine learning is, right? So you're here to learn, so let's start. So let's say this is our data set of cats, and this is my data set, and I have labeled it as cats. All right, so basically cats is your target variable. Got it? Cats is your target variable class, and other data that you have is of dogs, and the label is dog. So cats and dogs, these are basically present as your target variable. So this first image is classified as cat, this second image cat, third image cat, similarly this as dog, and so on, right? Now this data is passed on to your machine learning model, and your machine learning model learns on the basis of your input as well as your labels or the target, right? And now whenever you provide it unlabeled input, it will categorize itself, or it will predict whether the given animal is a cat or a dog. Okay, it will say this is cat and it will say these are dogs. Got it? So these are supervised learning algorithms. Got it? Any question? Feel free to ask. Fine. Sorry. Next technique is unsupervised learning algorithm. Now if you see here, we haven't passed anything. We have not given the target variable, right? We have not passed whether it's a dog or a cat. We have provided a randomized shuffled data set to our model. It's an unlabeled data set. Now what unsupervised learning technique does, it basically finds some patterns inside your data. For example, if you talk about dogs, so dog have small eyes, dogs have you can say ears that are actually below, they are not pointed. While if you see cats, so cats have big round cute eyes and they have pointed ears. So these kind of patterns are recognized by your algorithm, and your algorithm will then categorize these things. It will not predict, it will categorize the data into some ABC category and the DEF category. Now it's up to us whether we want to define it as cat or dogs. Got it? So these are supervised and unsupervised learning techniques. Okay, any doubts here? Feel free to ask. Okay, this should be interactive session so that I know whatever I'm teaching, you're understanding that. All right, now we will take a look at the machine learning tree. Just a second. Okay, so now machine learning tree is basically divided into two categories, main two categories that we already discussed earlier. One is supervised learning and second is your unsupervised learning. Got it? In supervised learning, we have two main categories. Those are regression and classification. So let's say if you want to predict the temperature or if you want to predict the sales, so these are in the numeric data, right? So the target is your numerical column, or it has the numerical data. So whenever your target variable is numeric, you need to use supervised regression algorithms, right? On the other hand, if you want to predict a category or a class, for example, if you want to predict whether it's a dog or a cat, if you want to predict whether the person has COVID or not, so for these kind of scenarios you will use supervised classification algorithms. Getting my point? Next category in unsupervised learning technique is clustering and association rule mining. So clustering algorithm you already saw, right? So clustering is basically what we did earlier. So we pass some data, a randomized shuffle data to our model, and our model found some patterns inside our data and categorized the data into some categories. That thing is called as clustering. While association rule mining, I will give you an example, a nice crisp example. Let's say you are married, right? And you are going into a Reebok showroom. Now Reebok showroom has applied association rule mining in their shop. Now you take a shoe. Okay, you pick up a shoe. You see, okay, the price is 2000. Fine, I will purchase it and I will go. Right now you are a registered member of Reebok. So Reebok will suddenly show you an advertisement on the screen that if you buy this sandal for your wife, you will get 20% off. Fine. So these kind of things are deployed using association rule mining, or in other words you can say recommendation systems. If you watch any Netflix series, then you get recommendations, right? So these are basically created using association rule mining. Okay, now these are some few methods or regression algorithms, that is linear regression, lasso ridge, all these things, regression trees, regression forest, support vector regressor, and all these things. Second, we have classification algorithms, right? Like logistic, decision trees, random forest, SVM, KNN, boosting, naive bayes, stacking, all these techniques, right? You don't have to worry about these things for now. It's just for intro. Now in clustering, we have a lot of algorithms, but I have mentioned two here, two main algorithms, that are K means clustering, hierarchical clustering. Others you have TSNE and DB scan. All these are your clustering algorithms. And in association you have a priori. A priori is basically used for your recommendation systems. All right. Okay. Now, before moving towards the framework for developing machine learning models, please ask me some doubts if you have regarding any of the technique. Few seconds pause for your doubts. Okay, no doubts as for now. Fine, we will continue now. Now from here, the main thing starts, that is how you design your machine learning models, or you can say what is the framework for developing the machine learning models. Fine. Now if we move ahead, and guys, basically my PPT will be mostly animated, or it will have pictures. It will not have that much text, so that it will be feasible for you to understand the concepts. Okay, so whenever you start with your machine learning models, or whenever you start creating these models, first step is that you need to understand the business problem or opportunity identification. Let's say, let's consider about one of the company. Okay, company X. Okay, company, or let's say company ABC. Now company ABC is hiring me as a data scientist, and now they have a problem. They are saying that they approached me and they told me that there is some issue with my employees. They are leaving after 2 to 3 months. And why is that? We are providing a good salary, okay, and our company name is very big, our company is very famous. Then why are they leaving my organization? Can you please find out, as being a data scientist or data analyst? Okay, so that is my business problem or opportunity identification, right? So I have to find out why my employees are leaving the organization, and if I have some data, I can also predict which employee will leave my organization, so that I can take some precautions or some chances. Got it? That is your first step. Second step is basically your feature extraction or collection of relevant data. Now you will say, okay, I accept your offer, I accept your problem, but I need some data. As being a data scientist, I need to have some data to be processed on, right? So the company manager will provide you a lot of data of their employees. Now that data will have the age of the employee, the relevant work experience of the employee, then whether the canteen food is good or not, how is the work life balance, then the favorite ice cream flavor of that employee, which ice cream he likes. Okay, and the last one is whether whether the employee left the organization or he is still there in the organization. Okay, so here we are creating a supervised learning algorithm. Why? Because we are having a target data, target column, right? Now it says extracting the relevant features, right? Now can you tell me, if the employee likes chocolate as the ice cream flavor, and if in the company canteen they are not providing chocolate flavor, then will is it the reason that the employee will leave the organization? Is it the scenario? No, right? Because of ice cream flavor, the employee will not leave the organization. That is not a relevant feature. So we will drop the irrelevant features and only keep the relevant data. All right, and once we have that relevant data, we will move towards the next step, that is the most important step in this whole pipeline, and it consumes around 80% of your task, and that is data pre-processing and cleaning. Now this data pre-processing, it includes basically the imputation of null values. So let's say if you have some missing values in your data, then how to deal with that. If you have some outliers, then how to deal with that. Or if there is some garbage data in your collection, then how to deal with that. All things are done in this process, or in this part, or the third part, right? Once you have the clear or the pure form of the data, you will move towards the next thing, that is called feature selection and model building, right? Once you have the data, you will select the features and build the model. So like you know that you have collected some relevant features in step 2, but there might be some features, or features are basically columns. Okay, columns are also known as features. So there may be some features or columns that are still not relevant for the model, or your model thinks that they are useless, right? So taking them out is your job in step 4. And once that's done, you will create your model. So model building is done. Once the model is built, is it of any use if you keep your model in your computer? No, right? You need to pass that model to the company ABC, so that the manager can use that data, that analysis, and he will be able to predict why the employee left the will the employee leave the organization or not. So the fifth step is basically your data analysis report, like what was the reason that your employees were leaving the organization. And so it is basically like some report dashboarding and your presentation kind of stuff. And at last you will deploy your models, right? So by deploying the model, that manager will be able to use your model over the cloud service. So this is the whole framework of developing your machine learning models. Okay, any doubts till now? Okay, I see. Okay, great. Acha, okay, sorry, my chats were not refreshed. Okay. Please ask your doubts if you have any. Sorry, I missed that. No, right? Okay. Now we will see some core libraries for data science, and we will study almost the majority of libraries in this series. All right. First is your Pandas library. Okay, Ravi is saying last 2 points are not cleared. Okay, let me see. So you are saying about fourth and fifth, right, Ravi? Okay. See, in fourth point, once you have the cleaned pre-processed data, in the fourth point, you will select some features, right? Now, let's say if you are thinking that age matters for the column or for your prediction, if you are thinking that age is the main feature to decide whether the person will leave or not, if that is your thinking, but your model says that that feature is not relevant, that feature is not contributing in the judgment, so you can remove the age column by using some. So basically, whenever you create a model, you get some data like whether the model is significant, whether the column is significant or not. And if you find that any of the column is insignificant, you basically drop that data, drop that column, and rebuild your model. Got it? And once your model is built, you start with your data analysis report. Data analysis report is basically creating the charts, right? Because the managers are non-tech person, right? Non-tech people, they will not understand your code, they will understand the presentation and the report. So here you communicate with them, you tell them what was the issue with their company, then you deploy the model, and that model can be used using their website. So using that website, they will be able to see whether the person will leave the organization or not. I hope my point is correct, right? Okay, understood the points now? Okay, please explain. Okay, Insha is saying, please explain difference between regression and classification again. Okay, see, regression is basically, first I will give you some examples and then I will tell you difference. Okay, now you have one data set where you need to predict the sales. Okay, second data set you have is you want to see, if you have car data set and you want to see in how much price your car will be sold. So that is your numerical data, right? The target is your numerical data. It has some numbers, right? A lot of numbers. So whenever you have a target numerical column, at that time you will use regression. Got it? And in the case of classification, let's say if you want to predict whether the person is having COVID or not, so what are the scenarios in your target? Either your prediction will be 0, or either it will be 1, or in other terms, either the person will have COVID or the person will not have COVID, right? You will not say that the person has 0.5 COVID, right? Either if you have 1, it means yes, he has COVID. If you have 0, it means he does not have COVID, right? So these kind of problems, when you see these kind of problems, you use classification algorithms. Okay, I hope my point is clear. Okay. Yeah, correct. Right. So okay, Chhatrapati is saying, sorry if I'm not able to pronounce the letters. So it's like, if you have continuous data, you are correct. If you have continuous data, we will use regression. Okay, because the numbers are either it can be 100, 101, 105, 107, 107.45. So whenever this kind of scenario is there in your target variable, you will use regression, else you will use classification. Okay, I hope you understood. Okay, guys, is my presentation blurry for all of you? Okay, someone is asking what is the difference between third and fourth step. Okay, see, third step is purely cleaning your data set. Third step is purely cleaning the data set. That means you perform all the data cleaning tasks. You see if it has null values, if it has not null values, if the data is correct, if it is not correct, if something is happening in your data, if you have some if you need to combine some columns or not, right? All these things, or you can say a massive cleaning happens in the third step, right? And feature selection using your model, it happens in the fourth step. Fourth step is not at all data cleaning. Okay, fourth step is not at all data cleaning. I hope I was clear. Okay, so now let's move towards core libraries for data science. Okay, I will take doubts after 10 minutes. Let's complete this slide. Okay, so first of the core library is Pandas, and Pandas is basically known for data manipulation. Pandas is a very hot library. It I mean, if you remember in the third step, I said we need to clean the data and manipulate the data, right? So at that time, Pandas is used. Pandas is used for data manipulation or data cleaning or data handling part. Second library that we will use is Numpy, that is used for your mathematical computations, right? For your statistics, you can say if you want to do something for statistics using statistics, then if you want to find the mean, if you want to find the standard deviation, all these things, then you will use Numpy. If you want to create matrices, if you want to create array, then you will use Numpy. Third is the data visualization library. If data visualization is not there, you will not at all understand your data, right? So data visualization libraries are matplotlib, seaborn, and plotly. And the core or the parent library or the ancestral library is matplotlib, and over matplotlib, seaborn and plotly are created. So seaborn and plotly are the children of matplotlib, you can say. They are the wrapper. Okay, next library we will learn is scikit-learn, and scikit-learn will be used to create your machine learning models. Okay, the next thing we will next library that is required is keras or tensorflow or pytorch, that are used for deep learning. And the last library set that we will use is scipy and stats models. So scipy is basically some advanced scientific computations. If you want to do, if you want to do some statistical modeling, then you can do. So if there are some things that are not covered in Numpy, stats models library takes care of that. Okay, and in this series we will learn almost 50% of, more than 50% of your libraries, that is Pandas, Numpy, data visualization libraries, and scikit-learn. Got it? Okay, now we are starting one of the most important concept, that is understanding the evaluation or performance matrices. If you don't know these things, then it is useless. I mean, the data scientist is useless, right? So you must know how to judge your model, how to know if your model is perfect or not, how to see if your model is performing well or not. Okay, so these are some performance matrices. So if you talk about regression, so there are few matrices in regressions, and there are few matrices in classification. Okay, there are a lot more, but all these are the but some of them are the mandatory ones. For example, for regression, mean squared error, root mean squared error, r squared, and adjusted r square are the most important ones. And for your classification, whatever I am showing on my screen, all these five are the important ones. Okay, we will study everything in depth, and don't worry if we are not able to cover all these in this session, all these matrices in this session. All these will be covered during your regression and classification sessions also. Don't worry, right? This is a session in which I want to make you understand everything in layman terms. Got it? Okay, some of you are saying it's blurry. I don't know. Okay, is it fine now or it's still blurry? Please let me know so that. Okay, okay, it's fine, right? Should I move ahead? Okay, okay, all right, okay, all right, let's move ahead now. Now you might think that I have put some cartoons and stuff, but believe me, if you watch any video or if you read anything from book, uh, at first you will not be able to understand the concept. So I'm just trying to explain everything to you in the layman terms. Okay, and that is the scene or motive of the sessions. All right, so you have an environment, and that environment is enclosed within this round cornered rectangle box. And in this environment you have the hippos, you have tortoise, right? And there is a model that is built over this environment, right? And this so left portion is your hippo side, and the right portion is your tortoise side. Okay. Okay, okay, someone is saying I enjoy cartoons. Okay, fine, great, great. Okay, now we are building a model, and what is this model classifying? That you have two categories here: either the cartoon is hippo or the cartoon is tortoise. So you need to classify between these two. All right, let me see the chat. Okay, okay. So now we have created this orange model. Okay, and this is classifying whether we have hippo or the tortoise, right? So if you see here on the hippo side, there is one misclassified part or misclassified animal. So the tortoise says that I am hippo, but he is not, right? So that means this is a misclassification on the hippo side, while on this side it's the tortoise side, it's the tortoise kingdom, but there are two hippos present here. The hippos say that I am tortoise, but they are not. That means on tortoise side there are two misclassified objects, and on hippo side there is one misclassified object. That is a simple term. Okay, now let's understand this using the matrix. If you see here, so actual tortoise is basically your tortoise side. Now how many of so these are basically predicted by your models. Okay, now how many of these tortoise are actual tortoise and they are predicted tortoise? So they are three, right? So the actual and predicted, the model has predicted three correct tortoises. So in this actual tortoise and predicted tortoise we have number 3. Okay, now on this actual tortoise side, sorry, yeah, on this actual tortoise side, how many predicted are, sorry, are misclassified objects? So we have two hippos that are misclassified, right? So actually these are hippos, but they are classified as, or they are predicted as tortoise. How many? What is the number? The number is 2, right? So here we have 2. Just look at this. Actually it is a hippo, but the model is predicting it as tortoise. So that misclassification number is 2. Now let's move ahead. On this left side, on this hippo side, actually this object is a tortoise, but the model says that it's a hippopotamus. So just take a look at here, this part. Actually it is a tortoise, but the model says it's a hippo, and the number of misclassified objects are 1. All right, now if you take a look at the hippo side, how many are correctly classified as hippos? So actually they are hippo and predicted as hippo. The correct classification is how much? 4, right? Okay, 4, right? Actually correctly classified hippos are 4. So that's why we have written it as 4 in this matrix. Okay, we will in the next slide we will take a look at the uh, purely big, I mean massive a matrix, right? And this matrix is known as confusion matrix, but I have named it as not so confusion matrix because it is easy to understand. I will make it simple for you, right? Now take a look at this matrix, okay? And this matrix says this is the same matrix, all right? Now this above portion, this axis of the matrix is predicted values, and this axis is the y-axis is your actual values. Okay, I hope you understood, right? Actual tortoise and predicted tortoise here, actual tortoise and misclassified tortoise here, right? Actual hippo here, misclassified hippo here, actual hippo here, and correctly classified hippo here. So we have this number 3124. All right, now take a look at this thing. So whenever the tortoise is correctly classified as tortoise, that is known as true positive. That is known as true positive. All right, now if the tortoise is actually tortoise but it is classified as hippo, that thing is called false negative. It is called false negative. Got it? Now if you are actually a hippo and your model says that no, you're tortoise, so that part is called false positive. Okay, and if you are an actually hippo and the model says that you are actually and the predicted is also hippo, that is called true negative. So correctly classified part is your diagonal. I am repeating again, correctly classified part is your diagonal. All right, so here so basically I have named this tortoise as the positive class and this hippo as my negative class. You can name either of them as anything. Tortoise can also be named as negative and hippo as positive. It's just for naming purpose. Okay, now whenever your class is negative and your model says that it is positive, then it's called false positive. Whenever your actual class is positive but your model says predicts that it's a negative, it is called false negative or type 2 error. Okay, now this part is taken from predicted classes. So whenever you are saying whenever you are declaring it as either true positive, false negative, true negative, always look for predicted class, right? So this was correct classification. So this positive was taken from, this word was taken from positive, just for your understanding purpose and so that you can remember. Here misclassification, the model predicted it as negative, okay, and the class is negative, so you can say that this one is false negative. Always go for predictive classes, right? So here also the model predicted it as positive, that's why it is known as false positive, and so on. Okay, Rukmani is saying please repeat false positive and false negative. Okay, false positive and false negative. Yeah.
Hello.
Yeah.
Uh,
Hi.
yeah, sir. Sorry for interruption.
No,
Sir,
it's fine. It's fine.
actually, yeah, Rohan is going to in.
Mm-hmm. Yeah, sure. Okay, I'm stopping my screen share.
Yes, yes.
Yeah.
All right then. Well, sorry for interruption, sir. First of all, but
No
and
worries
students,
at all.
please wait. But we have a segment right now, so you have to bear in mind. All right. So basically, we will be seeing a video right now, and after that, I'll be announcing a winner who will be getting a gift voucher from Amazon. All right. So moderator, can we play the video now? Okay. Viday, can we play the video now? That's awkward.
Hey, hi guys, this is Sai Kiran from LetsUpgrade, and I'm here today to congratulate you all guys for completing or like for pursuing our Essentials program in various fields what we do. And I want to tell that yes, this is amazing program what you're doing. But if you want to continue this learning and want to take your career to next level with a one-on-one personal mentorship, what we're not providing in essentials, and also build real-time projects, then join our 6 months PGP full stack program in data science or AI/ML or web development in one stack or Python Django. That's it. Bye-bye.
All right. So basically, not just essentials, we have multiple courses as well on our website. So you can check that out. Our mod is supplying the links for that as well. So first of all, aside from YouTube live sessions, so we have PGP courses. For example, Python, Django, web development, data science. We have multiple courses. And well, if you can guess the price, well, I'll not give you the chance, but trust me, it is way cheaper than you can think right now. And not just that, if you opt for one course, you'll be getting access to each and every courses as well. So let's say you want to learn Python, but you have an interest in web development as well, so you'll be getting access to that as well. You'll getting live sessions, you can get the recordings as well, and of course we'll have multiple projects with those sessions as well. So it will be great, and trainers like Shivam and multiple other trainers will be there for us to let you understand each and every topic, and you can have a one-on-one conversation with your trainers as well, who will make you understand whichever topic you want. So yeah, that is it. And right now I'll be announcing a winner who will be getting a gift voucher from Amazon. Well, today's announcement is based upon who was more interactive, and from tomorrow it will be based upon your attendance, which is happening right now. So you can just register, click on the attendance and please fill it in, so that next time when we are using a randomizer for from your attendance, you'll be getting a chance to win. So today's winner would be Shubham Mahapatra. Buddy, if you are there, then please let us know by sending a hi or something. And also please give us your email address. Please, you have to. And if you cannot fill in the whole email address, then please put the first half and space @ or something. Because sometimes YouTube may suppose don't let you add the Gmail address in the comment section. So please do that. Sir, can you see him in the chat? Shubham, are you there? Please let us know, because I cannot see the chat right now. So sorry for that. So you on mute.
Yeah, sorry. Shubham Mahapatra,
Yeah.
right?
Yeah.
Yeah,
Is it
yeah,
there?
he's there in the chat. Yeah, he's replying also.
Oh, great. But you do one thing. You have a social media handle, right? Moderator, please share the Instagram handle with him. So what you have to do is you have to inform us your full name, like basically DM us your full name, your phone number, and your email address, so that we can coordinate you. And you have to like get the Amazon coupon, but make sure you put it on your story so that other people gets to know about that as well. All right. So please DM us, and also right now please give us your email address, because it is very important. We want to verify it. Sir, has he shared the email ID?
No, I can't see here in the chat.
Moderator, can you see it? If you can, please give a ping to me. Huh. Shubham, like if you are not able to give the whole email address, please give the first part of your email address. For example, mine is Rohan, let's upgrade. Then I'll put space and then Gmail or something, so that YouTube doesn't avoid it.
I think whether he asks for email ID.
All right. So sorry for the due, but we have to wait for the email address, because of course upon that basis only we can give you the coupon. So sorry for that, sir,
Yeah,
but we
I
have
think
to
he
wait.
sent. He sent
He has sent.
his email address. Yeah.
All right, wait, they do one thing, just take the screenshot. All right, so we can rectify it afterwards. All right then, sir, please continue. And sorry students, if you're not winning it today, it's fine. Tomorrow you'll get another chance and you'll be getting a coupon, of course. So please come to the session and make sure you register your email address for the attendance as well. All right. So that's it from my side. Sir, you may continue now.
Yeah,
I'll be
sure.
leaving.
Thanks, Ron.
Okay.
Yeah.
Yeah.
Sure.
Bye.
Bye. Okay, guys. Let's start. I'm sharing my screen. Yep. Okay, please confirm me if my screen is visible or not. Quickly type V in your chat or visible in your chat. Okay, great. Thanks. Okay. Acha, it's not okay. For a few of you it's visible. For a few of you it's not. Okay, guys. Then I think we should start. Yeah, it's shared already. Team, can you check please if it's visible or not? Can you let me know quickly? Okay, it's visible now, right? Okay, great, cool. Okay, so someone was asking what's the difference between false positive and false negative, right? See here now, let's say we have this class, negative class. Okay, now if actually it is negative, right, but your model says that it is positive, or in other terms, if this animal actually is hippopotamus but your model says that it's a tortoise, then it is called as false positive. Okay, on the other side, if actually your class is positive or your class is of tortoise but your model says it's negative or it's a hippo, then that is called as false negative. All right, or that is also known as type 2 error. Okay, I hope you guys now have understood what confusion matrix is. All right, this thing is known as confusion matrix. Okay, I need two more understood so that I can say that we are good to go. I hope it's clear, right? Confusion matrix. Okay, cool. Okay, now why I took so much time on confusion matrix, because all the future concepts are related to this confusion matrix only. All right. Now, first classification matrix is accuracy. Okay, I have kept this confusion matrix on the left side. Now see the formula. So accuracy is nothing but your correctly classified diagonals. Okay, correctly classified diagonal sum divided by everything. Okay, so can anyone tell me what will be in the numerator? What will be in the numerator? What numbers will be there? Yes, Prakash, it's like yeah, it's like a matrice only, 0 0 0 1 1 0 1 1 kind of that thing. Okay, okay, that's correct. It will be 7. All right, so 3 plus 4, that is your correctly classified part, divided by all of the outcomes, everything. So divided by 3 plus 2 plus 4 plus 1, and that is basically your 7 by 10, or in other terms it is 70%. So you can say that my model the accuracy of my model was 70%. All right, my model was able to classify 70% of the data correctly. Okay, correct. All of you have typed correct answers. Cool. Okay. Now, accuracy has some issues. Let's see. Now, if your data set is imbalanced, guys, understand this technique, understand this part. This part is asked around 99% times during your interviews. That's why I have covered this portion. If your data set is imbalanced, then accuracy is the worst measure. Now, why accuracy is not suitable for imbalanced data? What is imbalanced data set? So let's say you have only 2 tortoises in your data set and you have thousands of hippopotamus in your data set, right? So during the training, how will the model know? I mean, how will the model be able to separate your data? How will the model be able to classify? Because there are only 2 tortoises. There is a very little probability that it will take those 2 tortoises in its training, right? Okay, MD Mohiddin is asking what is 7? 7 was basically your diagonal sum, true positive plus true negative. All right. So in other terms, accuracy is basically correctly classified divided by all of the classifications. All right. Okay. Now the example of imbalanced data set will be there are 10 tortoise while there are 990 hippopotamuses, and your total data set includes 1000 observations. Okay. Now one model, once you build the model, there is a probability that it will classify all the hippos correctly. Obviously all the hippos are correctly classified, but what about tortoise, right? What about tortoise? Tortoise are only 10, and if you see in this confusion matrix, let's say okay, let me make you understand it better. Let's say you have 10 tortoise and 9 sorry for my handwriting, is 990 hippo. Okay, now your model was correctly able to classify 990 hippos. Okay, but it was not able to classify any tortoise. Then also your accuracy will be highest. Why? Because accuracy is the sum of diagonal, so it will be 0 plus 99, sorry, 990 divided by 1000, and it will say that your model correctly classified 90 with the 99% accuracy. That is completely wrong, right? That is completely wrong. Why? It worked best for this category, but it worked very poorly for this category, and that's why accuracy is not at all always the best measure. I hope you understood. Okay. Okay. Okay, Chhatrapati is asking, what is the best ratio for training and test? See, guys, it's not a thumb rule. Okay, it's not a thumb rule at all. You can take 60-40, 30-70, 35 another as your training or whatever. It's completely fine. But the training data set should be more than your testing data set. All right. It's, yeah, it can be. No, it's, see, I am answering the question of Rukmani Kritika. Okay, will imbalance data set have more outliers? No, not necessary. Imbalance is always calculated on the classification part. Okay, we are looking at the classification performance matrices. Imbalance will always be there in classification part, and outliers is a concept of numerical data. Got it? Outliers is the concept of numerical data. It is not a concept of classification part. Okay. So we saw that accuracy has some issues, like the model did not, so it did the worst job in classifying tortoise, yet it got 99% accuracy. Okay. Okay, Vinay is asking, please explain the formula. See, it's simple. It is basically your diagonal sum, that is correctly classified part divided by all the parts. So Tn plus Tp, that is your diagonal, divided by Tp plus Fp plus Tn plus Fn. That means all the data in your confusion matrix are basically correctly classified divided by total. I hope I am clear. All right. Okay, great. Okay, now we are going for, now accuracy has issues. So what now? What other measures do we have? So we have two main measures that are known as precision and recall. Now guys, believe me, whatever video you will see on YouTube, they will you will be confused. Okay, so please focus here. I will try to explain this in very simple layman terms. Now, whenever you are considering precision, see, precision and recall are always calculated per class. So there will be a precision for tortoise, there will be precision for hippopotamus, there will be a recall for tortoise, there will be a recall for hippopotamus. Don't worry at all if you're not able to understand this completely, because obviously during our classification series we are going to understand this thing. Don't worry at all. All right, just understand that precision and recall are calculated per class. All right, so so now I am calculating precision for this tortoise side. Guys, we have a little time left, I suppose, but it's fine. Okay, Precision is basically your true positive side divided by true positive plus false negative. Sorry, false positive. Okay. So in simple terms, it is basically correct. Mansi's answer is right. So it's basically total tortoise correctly classified tortoise divided by total tortoise side observations. So what is a total tortoise? On this side there are 3, and what are the total tortoise side observations? All the observations on the tortoise side, they are 5, right? So this is 60%. Got it? This is nothing but your precision. Now if you had to calculate precision for hippopotamus side, then you will hide this tortoise side, and answer will be based on this portion. So precision for hippo will be, any guesses guys? Just tell me in the ratio format, no need for correct Mansi. It will be 4, that is correctly classified hippopotamus divided by all the observations on the hippo side. So 4 divided by 5. All right, correct. Okay, that's correct. Fine. Now what is recall? Recall is basically, consider if I want to find a recall for tortoise class, then consider only tortoise, ignore all the hippos. There should not be a single hippo present in your data set. Ignore all the hippos, take only tortoise. And recall is basically TP upon TP plus FN, or in simple layman terms, it is total correct classified tortoises divided by all the, sorry, here I have made a mistake. It's basically all the actual tortoises in your whole data set. All right. So total tortoise correct are 3, right? And all the total tortoise are 4. So basically your recall for tortoise will be 75. Correct. Many of you have answered. That's perfectly correct. Okay, so that is 75%. Now I think we will have to end with this last slide. I don't know, I will have to yeah, sure. So now what is precision and recall? What are the advantage of these things over accuracy? Precision is basically what you are predicting as positive actually is positive. All right, for example, email spam or ham classification. Okay, next is, so here if you see this part, if you get let us see the false positive case. Okay, you are getting an offer from Google, you are getting a offer letter from Google, but your model says that it's a spam and you will miss that email. So that is good or bad? Tell me in the comment, that is good or bad? You are getting the correct you are getting offer letter. Okay, that is bad, right? And your model is saying that it is spam, that is bad scenario. On the other hand, if you are getting a spam email, that is you won 7,000 rupees, but your model says it's fine, it's not a spam, and it stays in your inbox. Now which of the scenario is bad? False positive scenario or false negative scenario? Which is bad? FP is bad or FN is bad? Yeah, hi Anchal. Okay, sorry. Anchal is saying something. Okay. See, both are bad, but comparatively, I'm asking comparatively which is bad. If you get an offer and it's classified as spam, yes, okay, the FP scenario is bad, right? You are missing the opportunity. Google is ready to pay you, let's say 50 lakhs per annum. You are missing that opportunity, right? On the other hand, if you get any spam email in your inbox, it's fine. Who cares, right? That thing is fine in comparison to false positive case. So here we need to increase the precision score. Whenever you have this scenario, whenever false positive are the important ones, you need to increase the precision. Okay, while on the other side, if you are dealing with the disease classification, then false positive case will be the person does not have COVID, the person is perfectly healthy, but your model says that he has COVID. Okay, this is one scenario. Second scenario is the false negative case. The person is seriously infected with COVID. Okay, he's coughing and he's COVID positive, but your model says he's completely healthy. Okay, and the person is roaming in the crowd. So which scenario is bad? False positive or false negative? False negative is bad, right? Good, very good. So whenever you have this kind of scenario, you will say that I need to increase my recall. I don't have to worry about precision. I need the high recall for medical scenario data sets. You need high recall for medical scenario data sets. While whenever you have this spam classification kind of things, whenever false positive is the priority one, you need to increase your precision. Got it? Yes, Harsh is right. Your every data set metrics depends on your situation. Okay. Okay. Yeah, this thing you can see you are asking for examples, but everything depends on the scenario. All right. If you are classifying whether the person is having pneumonia or not, okay. Now, if your model says that the if actually he is having pneumonia, but your model says that he does not have pneumonia, that means he will not get a proper treatment. He will die. That means in this scenario, false negatives are most prioritized scenes, right? So here we will increase the recall. All right, I hope this helped, right? Correct. I hope this session was useful to you. Okay, any doubts, team? Do we have time or time's up? Okay, right. So unless and okay, it's up, right? Okay guys, so we will stop it here. Okay, don't worry about the other techniques. We will obviously study all the techniques during our classification and regression scenarios. Yeah, Ashwini, you are saying can you be little bit slow? See, I can be, but then you will miss out some topics, right? Yeah, but you are free to ask your doubts. I am ready to repeat the things again. Don't worry. Okay. So this session was basically basics, and if you don't understand basics, then you will not be able to move forward with any of the algorithms. So that's why this uh, session took this much time. Okay, guys. Okay, thanks a lot. Thank you. Okay, team, it's up to you. Guys, please fill the attendance form. Yeah, thanks a lot. Thanks a lot, everyone.